Density is always obtained by dividing mass of anything with its own volume. Now, in case of unit cells have mass because there are atoms in it. Suppose if you take a body centered cubic unit cell. So, body centered cubic unit cell also has mass because there are 2 atoms in it. You must be aware of the number of atoms present in each type of cubic lattice. So, the number of atoms in a body centered lattice is 2. So, because of 2 atoms, this unit cell has some mass. Now, how do you find the mass of one atom? Because you have got 2 atoms, so you need to know the total mass of 2 atoms to know the mass of the body centered cubic unit cell. Unless you calculate mass, you won't be able to find the density. So, how to find the mass of one atom? You see, if A is the atomic mass of any atom, and if atomic mass is taken in grams, then it always contains 6.023 into 10 to the power 23 atoms in it. You know, this is Avogadro's number, and we can write that as n. That's the usual symbol we assign for Avogadro's number. So, that means for n atoms, the mass is atomic mass taken in grams. So, for n atom, n means Avogadro number of atoms, you've got what mass? The atomic mass taken in grams. Then for one atom, the mass will be atomic mass divided by the Avogadro's number. This is how we can find mass of a single atom. We've got to divide its atomic mass by the Avogadro's number. So, this is how we can find the mass of a body centered cubic unit cell. Now, what about volume? 3 sides equal in length. So, because of that, the volume of the cube will be, if suppose this is the cube, if this is the cube, then if one of the side of the or edge length of the cube is A, then the other one will be also A, length A, breadth A, height A, then the volume will be, volume of this cubic unit cell will be A into A into A, that is A cube. So, what would be the density then? Density is mass. Mass is because of how many atoms are there in body centered unit cell? 2. For a single atom, mass is atomic mass divided by Avogadro's number, but since there are 2 atoms, so 2 times. This is mass of one atom multiplied by 2 gives the total mass of all 2 atoms present in body centered cubic unit cell, and divided by volume, which is A cube. Okay. Now, if this BCC is made by atoms remaining in the corners of the unit cell, this atom also has its own radius. Let us say the radius of an atom is written as small r, and in BCC you know that there will be one atom right at the center of the body center of the unit cell. So, the radius of that atom will be also r. Now, you are also supposed to know the relation between the radius of the atom that makes BCC and the edge length of the BCC. That means the relation between A and R. Now, this is the relation between A and R. A is the edge length of the BCC cubic unit cell, and R is the radius of the atom. The relation is A equals to, that is edge length equals to 4 by root 3 R. It is derived in those videos which I posted for solid states. Okay. So, I have to give you all these details just to solve a problem. The problem that one of you had posted. The problem is like this. Niobium crystallizes in a body centered cubic structure. If density, that means niobium is an element, it's a solid, and it forms BCC. If the density is 8.55 grams per cc, so the density is given, so we have to start solving this problem using density only. So, with the given density, we are supposed to calculate the atomic radius. So, first we'll start with whatever is given, that is density, and let's see what we can calculate. Remember, it's BCC, so the number of atoms in the unit cell will be 2. What else is given? We also have atomic mass, that is 93. Okay. So, let's solve this problem. I won't be copying the question, you just pause the video and just copy it from here. So, I'll start solving over here. So, what is given to us? We've got density of niobium crystal or its unit cell is how much? 8.55 grams per centimeter cube. So that's the density. It's also given that it is BCC, so, and atomic mass is how much? 93. Okay, so let's start with the formula of density. You know density is, look at the formula of density here. Density is 2 times A. Why 2? Because there are 2 atoms. By N, A is atomic mass, N is the Avogadro's number, A cube, A is the edge length of the BCC. So let's put the value of density. It's 8.55 equals to 2 times. We know atomic mass is the 93, and Avogadro's number is 6.023 into 10 to the power 23 into A cube. So this is the only thing which we don't know, A cube. It's A cube equals to 2 into 93, 2 into 93 divided by 6.023 into 10 to the power 23 divided by 8.55. So I just took this side, and that is, yeah. Now let me use calculator. Let me find it. This will be 3.611 into 10 to the power, this 23 goes up, minus 23. Now remember, the density, unit of density is grams per centimeter cube, and because of that the edge length, because there's centimeter here, will be in centimeter. I forgot to keep the so then A will be the cube root of this. So the cube root of this value is going to be 3.305 into 10 to the power minus 8 centimeter. So in terms of centimeter, that is the edge length. But we are not asked for edge length. Okay, so the question says that we are supposed to find the atomic radius. That means we are supposed to find R, and what we have got just now is the edge length of this cube. But since you already know that there's a relation between A and R, that is edge length and the radius, so using A we can find R. So what is the relation between edge length and radius? For BCC, that is body centered cubic unit cell, A is equals to 4 by root 3 R. That means R will be A into root 3 by 4, and since we know the value of A as 3.305 into 10 to the power minus 8 into root 3 divided by 4. So let me calculate this and give you the value of R. So this is the value of R, that is the radius of niobium which is being asked. Okay, you can even verify whether this is the exact radius or not from internet.